Test. Okay, thank you. Perfect. Sorry for the little delay. It's always my main issue in development. And I'm very happy to be here. Thanks, Amira, for this wonderful presentation. But don't worry, we are going to take some mathematic break and just jump into the Rust development. So it was very important, despite I'm not working anymore for the Ink team, to talk about this wonderful smart contract language called Ink. And the most interesting thing I've been part of was this audit with OpenZeppelin. So just after the Polkadot Blockchain Academy, I've been able to join a Parity team, and especially as a core developer in the Ink team. Just after, thanks to this Rust knowledge, I was able also to go to develop into the cryptographic team of Into. So Into is the main company that Amira was presenting and actually working, for example, on the threshold BLS integration in our protocol. So the main point between both experience was, in fact, Rust development, and it was, I can jump from the smart contract core development to the Rust cryptography, because during the Polkadot Blockchain Academy, we have such a range of knowledge we gained from the 5 weeks on site that you are able after to just go from different blockchain deep subjects. So you can wonder why Rust can be a good language for smart contracts. Yes, because Rust developer daily life is quite complicated. You have always to learn your language, and there is already Solidity, but why should you use Rust instead of Solidity, or just be a complement smart contract language? So Rust is memory safe. Also, when you compare to WASM, it's quite fast. And you can build just high-level function with Rust, and just don't damage the runtime. So you have also, of course, the minimum runtime. And what is amazing to use Rust in blockchain is that you will gain all from the Rust ecosystem. You don't have to create new tools. You can just use already command line tools. And especially, also you can, as it is compiled to WebAssembly, you will be able to also have this support for the WebAssembly ecosystem. But what is exactly the Ink I'm talking about? So Ink is just basically Rust. So it's programming language based on Rust. And the Ink team has been working on integrating all the smart contract functionality to be able just to produce smart contracts in a very fast way. So it will be compiled to WebAssembly. Just a very short overview of Ink is integrated in the Polkadot ecosystem. As I can spend maybe, I don't know, 1 hour to talk about this integration, but I will try to do it just in 1 minute. So smart contract in the Polkadot and Parity stack, it's just in top of the parachain. And you need to understand that if you want to deploy your smart contract, you need to have a parachain that have already a specific palette contract type that is called palette contracts. So a specific palette type that is called palette contract. So I think at the moment there's something like 6 or 7, I will say, parachains that have launched this palette contract in their parachain. So in production, there is Asta, Aleph Zero, Fala, and it's only this only one I can quote, but there are more. So also something that is you need to understand at the moment I'm talking about Ink, but for the palette contracts, if you can just create a new language, if it is possible to compile to WebAssembly, it will be very, very easy to integrate into the palette contract. So basically, what does Ink look like? So you will see either if you are a REST developer or smart contracts, it will easily remember you something that you already know. So just inside the contract, you have, of course, your storage where you will define of the value you want to use. Don't abuse about it. Don't put everything. It's not a database. And you will have your constructor to initialize your smart contracts, where you will initialize all the value of your storage. You have, of course, immutable function when you just need to read some function from your storage. And you have mutable function where you can, of course, change the value of the storage. You can just see that we always really just use Rust. So this is a global overview of what a very, very simple Flipper example smart contract look like. And you can find also the event type. So a short overview of a comparison between Solidity. The thing you need to just see is, on one side there is ink, and globally it just lies on the fact that it's just Rust and WASM. The only maybe, I will say, the thing that is a bit a constraint at the moment is the storage entry that is variable and goes only to int 128, except so 256 for Solidity. But we are in the audit, we are in the security tracks, so you are not expecting just to have a global overview of smart contracts, a very simple smart contracts. And let's jump into the audit with with OpenZeppelin. So this is an audit that has just happened at the beginning of the year. So it has begun from January 2023. And let's give some context about this audit. So it was an engagement funded by the Polkadot Treasury and supported by all the Polkadot ecosystem. So of course it's an audit, so the idea is to make it safer, so Ink, the smart contract language, but also the command line tool that is called cargo contracts. But if you are working with OpenZeppelin, you have to know they are not the cheapest company. And you want to gain also from all the developer and audit experts already from Solidity they have gained along the years. So the idea is really also to catch up, to catch all the insights they get from the Solidity world to implement this into Ink. So in fact, during this audit, there were three phases. And the first phase of this audit is just, of course, the review. There's, of course, a pre-phase where you are just helping them to understand your tool. And then the first phase is when, of course, they audit and they give this outcome, and then you work again. So this outcome was in first place. So we have 11 issues. You can see no one is critical. Of course, the severity classification has been reviewed by the parity security expert that is in this room. And sorry, Vincent, if you are here, he can confirm. And he has just reviewed all this severity classification. So you can see there is just two high severities issue. And I will, of course, not detail all the one, just this first very high security issue. So I haven't told you anything, of course, about Ink. And something that is present in Ink language is the selector. So selector is a way of identifying a message and a constructor. So it's help to just call them. And in fact, there is it's a feature that allows for developer to really modify, to hardcode this selector for a given function. And in combination with fallback function and proxy, it can reach that you call the unintended message. So it was not an easy it was not an easy issue to solve. I think you can ask all the ink team if some are present in the room. And so they decided so to just limit this selector to call only a fixed message. And so this issue is solved. And the second issue, the second high severity issue, is in fact a way how ink storage was implemented. So by default, all the different fields are stuck in a single storage cell. And especially when you do your upgradability, you can, in fact, you can the way the storage is upgradable can lead to undefined behavior. So at the moment, it's still open because the ink team is still working on refactoring all the storage composition of the language. So as I've said, it was not just a safety audit, it was also how to gain from all this Solidity experience and push a better developer experience. So they give some advice, of course, to communicate with more existing security auditing tools, and also to give more information, more updates. Also, something from Solidity's advice is to have immutable lag variables, and for this more recent command line tool that is cargo contracts, to extend more features, especially for the upgradability, and to get more information for your contract you are deploying. There was also a feedback for the education. So I think you all know Ethernote. And so the advice is really to have a comparison between Solidity and Ink smart contract to see how to not do, of course, all the bug and severity issues that can happen by writing your smart contracts. Something that is also very important, especially as it is Rust, is to really push to have funny tutorial, especially as you see that ink illustration is amazing. So it will be very a benefit to have this kind of crypto zombie tutorial. So what was the outcome of this audit? So 4 out of 11 issues have been resolved, others are still in progress. At last decoded, so the collaboration between OpenZeppelin and Parity was extended, and it will be about Parash and runtime templates that will be created with OpenZeppelin. And also, you can apply, there is an incubator, and you can apply for the audit tract. If you want to know a bit more about ink, of course, you can just go to use.ink, and you can apply for the audit tract. And in 2 days, there will be an amazing presentation by Geerman at paris.com. And you will be able to learn how it is possible. It's kind of experimentation. You will be able to see how it is possible to use zero knowledge with ink. So that's all for me. Thank you.